In this video, we're going to take a look at what bases are and quickly learn how to name and write formulas for them. So bases, rather than increase H plus concentration in solution, they increase something called hydroxide or OH minus concentrations in solution. Generally, a base would contain either OH minus, CO3 2 minus, or HCO3 minus because they all act in ways to increase the OH, even if they don't directly contain it. So as soon as you see something with hydroxide, carbonate, or bicarbonate, then you know you're dealing with a base. So sodium hydroxide is a base, sodium carbonate's a base. One exception that doesn't look like a base at all is ammonia. Ammonia is a base, NH3. You should memorize that. I'm just going to show you why ammonia acts as a base. As you can see here, this is NH3, this is ammonia. The electrons here are attracted to the hydrogen on the water because there's a bit of a positive charge on it, a little partial positive charge, we say, like not full, but kind of there. So the electrons kind of rip away that H and you get this here, this NH4 plus, but notice here you have this OH. So even though NH3 does not itself directly contain OH, it takes away H from water and increases the OH in the water. And that's what a base is supposed to do. So here you can see NaOH. You put it in water, it separates into Na plus and OH minus. This hydroxide is what makes something basic. How do you identify a base? The name of a base usually begins with a metal ion of some sort, not always, but usually. But what's more important is that it ends with hydroxide in most cases, if not carbonate or bicarbonate. So something hydroxide, something carbonate, something bicarbonate. Sodium hydroxide, sodium carbonate, sodium bicarbonate. How do you recognize a base from a formula? Well, bases are just ionic compounds where you have a cation, usually a metal or NH4 plus, and a polyatomic ion either being OH, CO3 2 minus, or HCO3. So if you see any of those polyatomic ions in the formula, then you're probably dealing with a base. So for example, NaOH has OH, Na2CO3 has CO3, NaHCO3 has HCO3. That's by formula. By name, sodium hydroxide, or by name, sodium carbonate, or by name, sodium bicarbonate. And of course, don't forget ammonia or NH3. If you hear that or see this NH3, then you know you're dealing with the base because it produces OH in some other way. Similar to what some of these would do as well. So now what we're going to do is we're going to take a look at how do we name and write formulas for bases. There's nothing different from what we've already learned from other ionic compounds. You name them as if they were ionic compounds. Just name the metal and the polyatomic ion. And then you write the formula just like you would any other ionic compound with crisscross. I would just put AQ next to it because bases are often aqueous. They don't have to be, but they often are. Acids always do have to be. And that's essentially it. So here I have the metal magnesium. And then here I have OH, which is hydroxide. Here I have the metal lithium. And then I have the polyatomic ion hydroxide. If you're getting the idea of this, you can just pause and try it yourself and then check your work after. This is something you had to memorize. This is ammonia. Here we have sodium and the polyatomic ion bicarbonate. So sodium bicarbonate. Now we have to make some formulas. So crisscross between aluminum and hydroxide. Aluminum is +3. Hydroxide is OH minus. Crisscross it. You get AlOH3, and we can put aqueous. Iron 2 hydroxide, similar idea. Iron is +2 based on the 2 there. Hydroxide is OH minus. Crisscross. You get Fe OH2AQ. Next, we have calcium hydroxide. Ca, that's +2. Hydroxide is OH -1. Crisscross, and you get CaOH2AQ. And then iron 3 hydroxide. Fe +3, OH -1, crisscross, and you get FeOH3AQ. So in this video, we learned what bases are. We learned how to identify them based on their name and formula based on the polyatomic ions they contain, which are hydroxide, carbonate, and bicarbonate. We learned about ammonia being an exception, so remember that one. And then we learned how to write formulas and name bases. So at this point, you are now able to identify and name acids. You are able to identify and name bases and also write formulas for all of these.